Okay, hi everyone. My name is Ronen. I work at the Fed Infra team from Israel, and I think that some of us are front-end developers, not all of us, but I think that especially for the front-end developers, but I think that for most of us, it's really important to understand. We all work with module bundlers quite a lot. Those are tools like Webpack and Rollup, and I think that for us, it's really important to understand how those tools actually work under the hood, and to really understand the process that they do when they take our code and generate it into this really big bundle that the browser is going to run. And this is what I want to do today. I want to help you understand how module bundlers work under the hood. And I'm going to do that in a pretty fun way. We are going to write our own bundler, a pretty small one, but still reasonably accurate one that will help us understand how most bundlers will actually work. So what even is a module bundler? So a bundler is a tool just like Webpack and Browserify. And today those tools do so many different things, so I really want to focus on their primary functionality, which is to let us write modules that work in the browser. And this is what our bundler will actually focus on doing. Modules are just a way for us to split code over multiple files. And we use module systems to describe when we write a certain module what other modules this module depends on, and when someone depends on a specific module, what the API that they are going to get. For example, in this module that I have right here, this module depends on another module called Lodash. And this module, when someone depends on that, that is the value that they are going to get. And those module systems are just a way for us to describe what dependencies a certain module depends on. This is how it looks in CommonJS, and those two module systems are pretty similar. And essentially, they have a few differences, but essentially they both just let us describe when we write a certain module, what it depends on, and what is the value that other modules will get once they depend on it. Module bundlers have this concept of an entry file. It means that instead of just having a few script tags that you put in the browser and they start running, we let the bundler know which file is the main file of our application. And this is the file that should kickstart and bootstrap the entire application. And what most bundlers are doing is that they will start with this entry file. They will try to understand which other modules this file depends on. And once they do, they will take every one of its dependencies and they will try to understand what other files they depend on. And they will keep doing that to their dependencies and their dependencies until they pretty much finish going over every module in the application. And once they do, they have this pretty good understanding about every module in the application and how they depend on one another. And this is called the dependency graph. And we are going to generate this dependency graph, and it will help us when we will bundle everything into just one file. And this is the model that many bundlers use to do other features that they deliver. And before I actually dive into writing code, I just want us to have a really high-level overview of the code that we are going to write. So we will write just 3 functions. The first one will just parse a single file. It will take a path to a file, and it will try to understand which other files it depends on. The second one will start by just parsing the entry file. Then it will recursively go over and extract the dependencies of every one of its dependencies and their dependencies until it pretty much finishes going over the entire application. And eventually, we will write a function that will take this dependency graph and turn it into just one file. I also prepared an example project, and let me just go over it with you. This is the example project that our bundler is going to work on. And we have an entry file. This entry file will depend on another module called message, and message will depend on a third module called name. So just a really simple linear chain of dependencies, and this is how it looks like on the IDE. So I have this example folder here. This is where the example project will be. And in this folder, I have this entry file. This is how it looks like. We import message for message and console log the result. This is message. Message is just importing name and exporting this message, which is hello name. And name is just Wix engineering. I wasn't too original with it. So this is the example project that we have. I think it's time for us to write some code. So I'm going to start by creating a new file. I will call it bundler.js. This is where the code for our bundler will be. And we will start by defining just a function that will parse a single file in the target application and extract its dependencies. So I'm going to go ahead and call it create asset, because it will return all of the information about this asset that we're currently parsing. It will accept a file name. And we would like to try and extract the dependencies of this file. First, I want to read the content of the file. So I will start by just, is this big enough? I think so. I will start by bringing in the FS module. This is a native Node module that helps us read, do file system operations. And I will get the content of the file, const, by calling fs read file sync. This is just a function that takes a path to a file and a format, and it gives me back the content of the file as a string. And just so we see that we can see our code actually doing something and making sure that it is OK, I will print the content, and I will also run this function and pass over the path to the entry file. So this is example/entry.js. Now, when I'm running the code, I'm going to just pipe it through JS Beautify and highlight. This is because I'm going to output a lot of code on the screen, and I think it will be easier for us to really understand and see the code. So running it, I think, again. So running it, we can see the content of the file that we read. This is the entry file. This is just this content right here. And this is pretty nice. This is just a string for us. And next thing, we would like to do something with this string and try to figure out which other file it depends on. And obviously, we can do things like look at the string and look for import, like import keywords or regexes or something like that. But this is pretty clunky. So instead, we're going to use a JavaScript parser. And I will try to really explain what a JavaScript parser is. So a JavaScript parser is a tool that can read and understand JavaScript. And it can generate a higher level model called an AST, which stands for an abstract syntax tree. And this is just a higher level model that tells a lot of information about the code that it is parsing. And we can gather a lot of information about the code. And let me just show you how it looks like. This is a nice tool called AST Explorer. And on the left, on your right, you can see the code that I'm going to put. And on the left, you will see how it looks like as an AST. And let me just put in the content of the entry file, so we can see how it looks like as an AST. This is the AST here, and this is just a JSON object eventually. This is what our code will work with. And this is just a tree view. This is just a nicer view for us to use, so I'm going to use that. But just keep in mind that this is just a simple JSON. Every node in the AST has a type, and the root node always has this type of file. And the file has a property called program, which has a type of program, obviously, and it has a list of statements. And those statements are the two statements. We have two statements here, which are the two statements that we have here. The first one is the import declaration, and the second one is the console log call. And those are also nodes with their own types, and they tell information about the code, specifically about this import declaration, like the source and the specifiers. We are going to get a JavaScript parser in our code. We will transform our string into the structure, and then we can see how we can extract the information out of it. So to do that, I'm going to bring in Babylon. Babylon is a JavaScript parser that I'm going to use. And we're going to generate the AST by calling babylon.parse. Babylon parse just takes the path to a file and returns the AST. And I will also just log the AST. I'm sorry, it takes the content of the file. Running it again, I'm getting this error. This is because we're using ECMAScript module, so I have to explicitly pass this option, because it's not on by default. And we got the AST. This is pretty much the same AST we saw earlier. We can see we have this type of file here. It has a program. This program has a body with 2 statements. This is pretty cool. And next, we would like to go over the structure and try to extract which dependencies this file depends on. And we can also just write our own function to traverse this tree-like structure. But instead, I'm going to use a third party to help me do that. This third party is called Bubble Traverse. I will bring it over by importing it. Traverse. And I think this is an ES module. And the way that Bubble Traverse works is that I don't need that anymore, is that it's a function that accepts the AST. And the second parameter is an object with visitors. And essentially how it works is that I can choose, it has a few ways that it can work, but for me, I would like to just only iterate, I would like to just look for import declarations that I have inside the AST. And if I want to only iterate on import declarations, I can just take the type of the node that I want to iterate over, and use it as the key in this object, and have a function as the value. And what Bubble Traverse is going to do is that it will run this function for every import declaration that it finds in this tree, and it will just pass over the node right here. So I can just this function will run specific for every import declaration in the AST. For us, this is going to be just once because we have just one import declaration in this file. Just so we see that it's OK, I'm going to console log the node. Console log, come on. OK. And we should hopefully see just one log. OK, looks OK. And this pretty much nice. OK, so we have this import declaration. And it has information about the import, like what we're importing, where we're importing, and maybe some more. And now we want to basically try and extract the information about which file we're actually depending on and which file we're importing, and collect all of those. So to collect all of them, I'm going to define an empty array. I will call it dependencies. And whenever we find an import declaration, I'm just going to push the value into the dependencies array. So I will just push into the dependencies array, and the value that I'm going to use is just I'm looking for this value, which is the path that we're importing from, and this is just available as the source.value property to the import declaration. And this is something really nice about ECMAScript modules, is they are static, which means that I can do something like this. I can dynamically import a module, at least not like that. And I can't conditionally import it. If I wrap it with an if, it's not going to be valid either. This thing has to always be static, which means that I can count on the source to always be a string literal, which means that whenever I find an import declaration, I can just get the node .source.value, because this is always just going to be a path to a file. So I can count on it to always be here. And now we're just, whenever we find an import declaration, we just take the source and we push it into this array. And I'm just going to log the array just to make sure that this is that we got it correctly. And I'm going to run it again. And this is fine. We got just one input. We got this array with just one path to message. And this is pretty much us collecting all of the dependencies of this file. And I just want to have one more property to every asset that we have. I want every asset to just have its own unique identifier. So to do that, I will just have a very simple counter, which I will initialize to 0. And whenever we parse an asset, I will assign an ID for that by just incrementing this counter. And eventually, I will just return an object with all of the information about this specific asset. I'm going to just pass over the ID, the file name, and the dependencies that we have collected. So essentially, now we have this create asset file, which takes a file name, reads its content, parses it with into an AST, and go over this AST to collect every one of its dependencies, assigns an ID for that, and returns all of this information. So now when we parse the entry file, we should be getting the main asset, which should just be an object that looks like that. So I will console log it just to make sure that I got it right. And looks OK. Cool. So the next thing I'm going to do is that we're going to write a function that will start by parsing the entry file. And then it will go over every one of its dependencies. In the case, this is one of those. and it will do the same for them. It will read their content as a string, it will parse them as an AST, and it will extract their dependencies, and we're going to do that recursively. So to do that, I will define another function called createGraph. This function will essentially just do what I just said, and it will create the graph for us. And it will start by just parsing the entry file. And I just want to make a small change here. Instead of having the path to the entry file hard-coded here, I will just get it as a parameter. And I'm going to just call createGraph right here. And I will pass the path to the entry file. And this will give us the graph, which we are now going to actually create. So this function is going to start by parsing the entry file, which we are doing. And next, I want to go over every one of its dependencies. And I can do that by recursively, or I can do that with a queue. I think it's simpler to do with a queue, so this is what I'm going to do. To have a queue, I'm just going to have this empty array, which will initially have just the main asset. And I'm going to iterate over this queue. And the way that it is going to go is that this queue only has just one element. I'm going to write a function. I'm going to write to iterate over after every element in the queue. And run and extract every one of its dependencies, like parse every one of its dependencies with this function. And once I'm done, I'm going to push new assets into this queue. So this queue I'm going to keep iterating this queue again and again until I didn't push any new element into the queue. So to do that, I will use a for-of loop. A for-of loop is just a way for me, is just a queue that helps me iterate over every value in the queue. So I'm just iterating on every element in this array, every asset in this array. Those are just objects that look like this. And as I iterate this on a certain element, I'm going to just push every one of its childs into this array. So whenever we iterate on a certain asset, we would like to go over every one of its dependencies. I can do that by asset.dependencies.for each. And those are just those dependencies. And if you take a look, this is a bit confusing. Those dependencies are just an array of relative file paths. And they are relative based on the file that actually imported them. So if I go back to entry.js, I'm importing message for message, and this message path is just relative to where this entry.js is actually in. And if we take a look, we want to just go over every one of those dependencies and parse them and create an asset out of them, which means to extract their dependencies. And this function accepts an absolute file path. And if you take a look, this is just a relative file path, so I'll need to somehow turn it into an absolute file path. And to do that, and this relative file path, it's relative to based on where this file is actually importing to where this file is located, which is the example folder. So to resolve all of those, relative file paths, I'm going to bring in another node module called path. Path is a native node module that helps me, has functions to help me with file system paths. And whenever I iterate over those dependencies, those are just an array of relative file paths. So I can just call it relative path that we're iterating over. And whenever I find a relative file path, I would like to resolve it based from this directory. So to get this directory of the file that we are going over, this is something that I can do here. I can just the directory name of the file that we are parsing, which is this asset, which is initially just the entry file. I can just call path.dirname, which will give me the directory that this file is in. So this is just asset.filename. And this is going to just give me the path to the example folder. This is the folder that contains message. And then as I'm going over those relative paths, I can just turn every one of them into an absolute path by just resolving this relative path from this directory. To do that, I can call path.join, which just joins two paths. I can join the directory name of the parent with a relative path, with this relative path. So that should give me the relative path to this message file. And then with this absolute path, I can just generate a child asset by calling create asset and I can pass over the absolute path. By doing that, that will take this path to this message file. and it will run it over with our create asset function, which will read its content, parse it as an AST, and extract every one of its dependencies, along with assigning it an ID. Now that we've actually parsed this child, we're trying now. Currently, what we have is that every one of our modules, every one of our assets is an object that looks like this, and we're really interested in knowing the relationships between those assets. And currently, we don't have any relationships in between them. We just know that this this object has a dependency on this relative path. But now that we've parsed it into an asset with its own ID and its own parameters, we would like to create this relationship. So to help us do this mapping between one module and its children, I'm going to assign a new property to every one of our objects. Whenever we parse an object, I'm going to assign a new property to it called mapping. And I will just initialize it into an empty object. And whenever we parse a child object of this asset, I will just add a new property to these mappings that will tell us that this parent asset has a relationship as a dependency on this child object. To do that, I'm just going to assign a new value to it. I will use the relative path as the key. This is just this relative path. And for the value, I will use the child ID. This is the unit ID that we've assigned here. This will just tell us that, hey, this module has a dependency on this child. And now that we've basically, this is going to go over every one of those childs and parse them and make sure that they are mapped. But we would also like everyone to also do the same thing for every child, which means that we'd like this child that we've parsed, we would like to go over every one of their dependencies and also parse them and create that mapping. So to do that, I can just take this child, which is already an asset, and just push it into the queue. I can do that by calling just queue.push and add in the asset, the child asset. That means that the next time I iterate the queue, the next time this for loop is going to run, it will have a few more child elements into it, which means that for every one of those child elements, we're going to assign the mapping object for them, go over every one of their relative paths, turn them into absolute paths, and parse their children, and it's going to keep going and going until this until the queue is empty. And once we finished adding more and more and more child assets into the queue, and once we finished going over the queue is just going to be an array with all of the modules in our application. This is pretty easy for us because we're going to just represent the graph as just one big array with all of the modules in our application. So once we finish iterating the queue is going to be just an array with all of those modules in the application. So this is really convenient for us because I can just return the queue. And this is just an array with every module in our application. So I'm going to just log the graph so that we can see if this actually went correct. Cool. So this is how our graph currently looks like. So it's just an array with objects. And we have the first object is what we looked earlier. This is the entry file. It has the ID of 0. And now we know that it has a dependency on this relative path to message. But we also know that this message is actually dependent on a module with the ID of 1. And we know that this is this module, which is message. And message has a dependency on name, which is module 2, which has the ID of 2. This is this one. And it has no dependencies. So this is essentially already a pretty good understanding of the project that we are trying to bundle. Because we know about every module in the application, and we know about the relationships in between them. And this is really powerful understanding of this project, and we are going to use that now that when we are going to bundle it into just one file. To do that, I will define a third function called bundle, because it is going to bundle. So the way that bundle is going to work is that it will just take the graph as a parameter, and it will return just one large file, which I will just one big string that we can later on just save to the file system or something. And let me just call bundle here and get the result. We will implement it in a moment. And I will just pass over the graph. And I will just console log the result, which should be just this this bundle that we are going to be able to run on the browser. The way that this bundle is going to look like is that it will be just one self-invoking function. And a self-invoking function is just a function that I'm going to call immediately. And I will pass in an object. And the way that this function is going to look like is we're actually going to write the implementation for this function in just a bit. I want us to focus first on this object, the object that we are going to pass to this function. And this object will contain information about every module in the graph. And I'm going to construct it. It's going to be a bit complex, so we will construct it outside. And I will just put in the result here. I'm going to call it modules. And this is an object that we will just create outside, just a string. So I will just initialize it into an empty string, and we will create it here. And this object should contain information about every one of the modules in our application. And to do that, I'm going to just iterate the graph, which is just an array of modules. So I can just iterate. Whoops. So I can just iterate the graph by calling graph.forEach. And for every module in the application, I will just add the information of this module into this string. So I can just call modules and just keep adding new values for it, for every module. And if you take a look, this is a bit confusing, so pay attention. I'm opening an object, I'm opening a curly brace here, then I have this string here, and then I'm closing the curly brace. So this is an object, so this module string should just look like this. It should just have key, colon, value, comma, key, colon, value, comma. So I'm going to just create it here. And for every module in the graph, I'm going to, for its keys, for the key, I'm going to use the module ID. Module is just an array of objects that look like this. So every one of them has its own unique identifier. I'm going to use the object ID as the key, then colon, and then the value. And for the value, I'm just going to use a tuple. This is just an array, a fancy name for an array with two values, because we will need more than just one value for every module. And if you think about it, when we just run scripts globally in the browser, when they define variables, like for here, when we have this import message is a local variable to this module. And I can also just define just normal variables, like something like that. And normally the way that this will work in a browser is that this foo variable will be globally available for every other script in the browser. And this is not how modules work. Modules have this notion that every module is scoped, and every module has its own scope. And variables that I define in one module won't leak to other modules. And we need to emulate that when we write our bundler. So to do that, I'm going to put the code of the user here, but I'm going to wrap it in a function. This is because so that every variable that we define in the user code will just be scoped to a certain function. And I also can't just put the code of the user just like that in a function, because we're using features that are not supported by all browsers. Like we use imports and exports. We might be using const, lets, arrow functions, which are not necessarily supported in every browser. So I will have to transform this code into something that most browsers can understand. And I'm going to use a JavaScript transpiler for that. And let me just explain real quick about that. So JavaScript transpilers, I'm going to use Babel as the transpiler. And Babel is a tool that can take JavaScript and change it into different JavaScript. And I'm going to use it to make my code run on every browser. And the way that this is going to work, let me just have an example, is that if I have an import statement, will actually transpile down to something that looks like this. This is just CommonJS. As you can see, we're just calling the require function, and we're just changing ECMAScript modules into require.js with require module and exports. Just using consts is going to transpile over to just using var instead. So essentially, we are going to use Babel as a tool that will take our JavaScript code and transpile it into something that most browsers can understand. Even if we actually use, even once we transpile our import declarations into something like this, CommonJS, this is still not supported in the browser. The browser doesn't have this require function or this module and exports object. So we will have to implement them, but this is not different syntax, which this is the case for import declarations. This is just a function which we can create. So I'm going to just make sure that our code we transform the code of every one of our modules from this option to this way. And to do that, the easiest way for me to do that, the easiest place for me to do that, would actually be in this function, this create asset function. So when we go over the code, we have the content of the user, and we can just transform it with bubble. So I'm just going to bring in bubble. Whoops. Cool. I am just going to get bubble, and I'm going to generate the code out of by running bubble. And bubble has a few transformation functions. I can just transform from a string, from a file, but we are going to use transform from AST because we already have an AST. So I can just pass over the AST. The second object is just the content. We don't care about that. And the third argument is an options object. And we really care about just the presets option. And presets is just a set of rules for us to tell Bubble how to operate and how to change our code from one way to another. And I'm going to use the simplest thing, which is called Bubble preset env. Bubble preset env is essentially just a way for us to make sure that our code transpiles to something that will run on every browser, on every one of the important browsers at least. And we can take this code property, which is going to just be this really big string. And I'm going to just expose it for every one of our modules. So essentially, whenever we parse a certain module, now we're going to also have this code property, which will contain the transpiled code. Let me actually just make a small change here of just console logging the graph so that we can see that our graph with the change of bubble. So now every one of our modules in our graph is going to be transpiled with bubble. And this is the code property that we've added. And this is how it looks like. We have this use strict statement here. We have a variable. Instead of const, we transpiled our imports into require calls. And we also use module and exports. So going back to creating the bundle. So essentially now that we have this function here, which is going to wrap the code of the user. So we emulate the scoping. And I'm just going to put the code of the user here. This is like a really big string that we're constructing. This is just module.code. For the second, let me just see how it looks like. So this is the bundle that we're currently generating. We have this empty function, which is currently not going to do anything. And then we pass this object. And we have the module IDs as the keys. And we have arrays, which currently have just one value for every one of the modules. And this is just a function that wraps our code. And if you take a look, we have the code of the user is now calling this require function. And it is passing a relative file path. Now, we may have a situation where two modules require the same relative path, but they mean two different modules. And I would like to know that, hey, that this relative string is actually like I would like to know which module in the graph when we implement the require function, which module in the graph we should actually give to when we implement this require function, we should really know which module in the graph should be returned from this require call. So I would like to know that, hey, this relative path points to a certain module in the graph. And this is something that we already have available as the mapping object, as these mappings. So I'm just going to just make sure that this is the second value available for me here. This is just module.mapping. And I'm going to stringify it because it's an object. So let me see how it looks like. If you remember, the mapping is just an object that has the relative path for this file and the absolute value of the absolute module ID as the value. So essentially, these mappings are just something that tells us, hey, whenever you see a relative path to message, you should give me module number 1. And we know that this is the module right here. This module has this call to name, which is just a string as far as we're concerned, but we know that we should give it module number 2. This is pretty much all of the information that I'm going to want to have about every module in the graph. And the rest that we're going to do is just implement this function, because running it currently isn't going to do anything. And I'm going to just have this object here, which I will just get here. I will call it modules. And the way that this object is going to look like, the way that the implementation of the function will look like is that I will have a require function. We will have to create it. And once we do, we will just require the entry file. This is the module with ID of 0. And this is essentially going to just make sure that the entry file is going to run. And it should really kickstart the entire application with other requires to other modules. So back into the require function. This is a function that takes a module by its ID. And we already have this object here, which is indexed by module IDs. So it will be really easiest for us to get them. I can get the module by looking at the modules object for the ID. This is going to give us an array with those two values, so I can just go ahead and destructure over them. The first one is the function that wraps the code of the user. This is just this function. And the second one is the mappings object. And once then, we will need to just run this function. Now, we use CommonJS, and CommonJS expects a few variables to be available. Those are essentially the require function and the module and the exports objects. So this is something that I'm going to inject into every function wrapper that we have into the code. So the code has those variables available for them. This is just require, module, and exports. We will have to also implement them and pass them as we write the bundle, before we run this function. So if you take a look, every function has a require function which works a little bit differently because it works based on its own mappings. And we may even have two modules which require the same path, but they mean two different modules. So I'm going to create a dedicated require call, a dedicated require function for every module. So essentially, I'm going to call it local require. This is going to be just a local require function for this specific module. And also, if you take a look, this require function takes a relative file path, and our function takes an ID. So I will have to do this mapping between a relative path and turn it into an ID. And this is why I have the mapping for. So this local require is going to get a relative path. This is the relative path. And it will have to call the real require function. This is this function, and just pass an ID. Now we have this relative path, and we would like to turn it into an ID, and we can just look at this mapping object right here and get this relative path into an ID. So this is essentially just, we have this mapping here. This is this object right here. I can just take this mapping object and look for a relative path in it. That should give me the ID, which I can pass to the real require function. And I can just return the result. And the only two objects that I need to implement are the module and the exports object. And the way that CommonJS works is that the code that we have runs, it expects this export object to be available, and it assigns new values to this export object. And eventually, once this function finished running, it is going to return when we require this, when we depend this module, when we require that, this is the object that we are going to get once we require this function. This is this thing that we, when we require it. So to do that, I'm going to define this module object. The module object is an object with just one property, which is exports, which I will just initialize into an empty object. Let me just call it local module. And next, I'm going to run the function that we're requiring. This is this function wrapper. And I'm going to pass every one of those variables. I'm going to pass the local require as the first one. I'm going to pass just module and module.exports for the exports object. And now that when this function is going to run, it is going to mutate and change this, this export object. And eventually, when this function finished running, I'm going to return the new and changed module exports object. Local, yeah, thank you. This is indeed local module. And I can just return the local module.exports. So essentially, this is what the require function is going to return. And if I got all of that correctly, I should be able to run the bundle and get the result. But before we do, let's just make sure that we remember what we're really trying to achieve here. So we have this entry file. Let's see if we can see what will actually happen. So we have this entry file. This entry file imports a message for message, and it console logs the result. So we should be seeing something logs on the screen. Message is just this message, hello something. And this is eventually just going to be hello Wix engineering. Let's see if this is going to work. I'm going to run it. Now we have a bit of runtime code that we've added right here. So I'm just going to copy that. And I'm going to just run this code. And hello Wix engineering. And I think this is arguably the most complicated hello world I've ever done. But I think that what I want you guys to take from that is that those are really I think that most of us, I think that it's important for us to really understand that module bundling is not just concatenating a few strings together, it's much more than that. And also the fact that understanding a few of the moving parts inside it. And I think that I really hope that you guys take some of the moving parts here and look maybe at Webpack, at Parcel, which has a very approachable code, and try to see if you maybe can contribute into them, or maybe, I don't know. Yes, yeah, that's it. Hope you enjoyed.